Alright, hell yeah. So my brother got me linear algebra, you know what I mean? And he got me the actual textbook, so that's pretty sweet. And so, man, I struggle at reading in general. So my comprehension's real low. I just read simple novels and stuff, you know what I mean? Simpler the better. But oh man, I can't read text. I can hardly, yeah, so I just want to see what they did and then just repeat it. So that's what we're going to do. We're going to do the Gaussian elimination. You know what I mean? So we're going to, this is all about matrices, which is just very fascinating. So, but before we get into the matrix, let's just figure out how I solve this just normally. And they eventually solve for z. That's the first thing they want to solve for. And I at least know that if I don't take this equation and solve for z and then shove it into the other, my z will disappear. Like, just think about this. If I get all this term and this term on the other side and then divide by 4, I'll get z is equal to, we can even do this, negative 13 minus 3x minus y, but then all divided by 4, cool, that's z, and then I'm going to go shove it into this equation, you know what I mean? And then we'll have to solve for x or y. Let's say we solve for y is equal to, like, all this stuff over there, maybe get the y's together, and then have something, and then I'm going to shove that in for y. Oh, and I guess I would have to shove another one in for z too. And then, oh, so yeah, so just kind of interesting. So how would I, yeah. But, so I'll solve for this x first. So that's the first thing we're going to do. We're going to say x is negative 9 plus 3y minus 5z. Cool. So now I'm going to shove this x into here. And this might be the dumbest way to do this, you know, because now we have 2x. I at least know that I can just do that right now. I can go 18 plus 6y minus 10z. But I'm just doing this real time to see, like, oh, is the Gaussian elimination just like bee's knees? And obviously addition, like, I mean, for sure, like, this is probably the worst way sometimes, or just all the time. But this is the kind of the way that I would do it. And let's say we did this. I would have y and z, I would shove it into there, sweet. But I at least know that we need to shove this into this equation too. So I'm going to say 3x is negative 27 plus 9y minus 15z. And the other thing about this book is just like, well, even what I'm doing right now, hella room for error. You know what I mean? Errors all over the place. We might be making them right now. So let's do it. So we're going to shove this in right here. And we're going to get this equation is going to be negative 18 plus 6y. I'm just going to do a couple things at once. Plus 6y minus y. That's going to be plus 5y. I can't write a lot because my, you know what I mean, I don't know, my joints hurt. Anyway, so now we have minus 10z minus 3z. Sweet, so that's going to be minus 13z. Alright, so we did a couple steps at once. Not too crazy. And now for this one, we're going to throw it in here. So we're going to have negative 27 plus 9y plus another y, so that's going to be plus 10y, minus 15 plus 4, that's going to be minus 11z, is equal to negative 13. Cool, this equation has y and z, this equation has y and z. So now we're just down to just pretend that we just have two equations with two unknowns. And instead of 3, so we're done with the 3 equations. We should have got, hey, we should have done this. So this is plus 18. 9 plus 8, I don't know what that is. 8 plus 8 is 16, 17. Cool. So that's 37. So we just did that. So we have 5x minus 13z is equal to 37. This one, we're going to add 27. I don't know how to add a negative number plus 27, but I do know that 27 minus, why does that work? You know, let's figure out why that works. So I was just going to do negative 13 plus 27 and just not know what the hell's going on with life. And that's going to be a positive number, you know what I mean? So we at least have that. And what was I going to do? I was going to do 27 minus 13. Why are those things the same? I have no idea. So that would be 14. 27. Oh, because I can, oh, because this is associative? Is that what it is? Associative, where you can just, hey, negative 13 plus 27 is this. I've never done that before in my life. Holy, look at that. That was magical. That's just 27 minus, we just proved that. You know what I mean? So that's sweet. Cool. And that's going to be 14. So we're going to go 14 there. All right, let's clean this up. So we have 5y minus 13z is equal to 37. See, I'm already making mistakes. And this is 10y minus 11z is equal to 14. Now, like I went through my entire college career with never subtracting these things, you know what I mean? Because I was never forced to, you know what I mean? You just figure out your own little ways to solve things. But obviously, you would multiply this by 2 and then subtract them, and then you would just be golden. But we're not going to do it that way. We're going to do it the slow way. Okay, so we want to know what z is, so we're going to solve for y up here. Is that going to be the easiest one? I think let's solve for y down here because we can just divide things by 10. So we're going to go, so this is going to be 10y is equal to negative, oh, sorry. When we bring this to the other side, it becomes positive. So 11z plus 14. And hey, y is just, I'm just going to do this, it's just divide by 10. So 11 divided by 10, well, I know that's 1.1z. That's why I did that. 14 divided by 10 is 1.4. Sweet. So so now we have that. Or we could just leave it in 11 tenths z plus 14 tenths. There we go. Let's leave it like that. And then I would shove it into here. I don't know what 5, but so we're going to have this going to be 5y. I mean, sometimes I would just actually just do this. I would go 5 and then 11 tenths z. I at least try to reduce my steps just by a little bit because writing too much is crazy. Okay, so this is going to be 55 tenths. So we have 55 tenths z plus 14. I don't know what 14 times 5. I know what 7 times 10 is. That's 70. All right, so that's plus 7. All right, and then minus 13z is equal to 37. This is 7, and then I'm going to subtract it from the other side, so I'm just going to do this. So, hell yeah. And then, this is 5.5. Oh yeah, so we're not bad. So we got 5.5z minus 13. Let's do that again. 5.5 minus 13. Oh yeah, this is a bummer because now we're going to get into a negative number. Could we move this around too? Could we say this is negative 13 plus 5.5? That doesn't really help us though. Not at all. I don't know why this. I don't know what all the. Yeah, I need to learn more tricks when it comes to this to not make mistakes. But yeah, 5.5 minus 13. Like holy Toledo. I don't even know. Yeah, if I had this on a test, I'd be like, nah, I'd pass. 13. Let's just do 13 minus 5.5 and see where we... I don't even want to do this. 13 minus 6 is 9. 13 minus 5.5 is 9.5. I think I'm just making my is that so we're going to have negative 9.5? Let's prove that. So we have a negative 9.5. So we had 5.5 minus 13. And so we're going to get negative 9.5, and then we're gonna subtract another 5.5, and this should be 13. Oh no, what did we do? Holy Toledo. Wait, negative 13 plus 5. Why am I getting tripped up on this? Yeah, I need to find better methods because this is blowing my mind right now. So if I did negative 13 plus 3, okay, that would be 10. That would be negative 10. And then negative 13 plus another 2, that would be negative 8. And then negative 13 plus another half, that would be negative 7.5. So I was off there. So this did, none of that stuff worked. So anyway, So we have negative 7.5. I couldn't see that. So a negative 7.5z is equal to 30. Okay, sweet. So yeah. So z is equal to bring the negative set. So negative 30 divided by 7.5. And I don't know what even that is. So we're just gonna holy Toledo! I felt like I just made huge amounts of mistakes. There's no way this could be right, but we'll go with it. And we have to break out the calculator. I can't do just simple. Oh, that's just negative 4. How could I have not gotten there? Or how could I have gotten here? How could I figure out this was... Oh, well, let's try it. So we have negative 30. What's 7.5? 7.5 is 14... No, it's 15 divided by 2. So if I have negative 30 and then 15... Yeah, I needed to work on more of my math skills. You know what I mean? Not using the calculator and stuff. So if we had 15 divided by 30... Negative 30 divided by a fraction is the same thing as negative 30 times 2 divided by 15. And so that's going to be negative 60 divided by 15. That's negative 4. Sweet. So z is negative 4. And I haven't even looked up the answer. I'm just kind of going for it. Okay, so we got z is negative 4. Oh man, we should probably just stick with one sheet of paper, because what we have, we at least got it down to these two equations right here. And so yeah, we still want to stick with this. So if we get z is negative 4, we can throw negative 4 into either one of these. Let's do it to this one. So we're going to get positive 44. And then we're going to, yeah, that's going to be positive 44. Subtract it to the other side. So that's negative 44 plus 14. That's going to be negative 30. So sweet. So we have negative 30 over here. And y has got to be basically negative 3. So sweet. So y is negative 3. Wasn't too hard. And then now we go back to an equation that has x in it. We can go to any one of these. Which one looks the simplest? None of them look simple, but we'll go this one. So we're going to say x is negative 9 plus 3y minus 5z. Let's just rearrange that. And so we have 3y is negative 9. So now we have negative 18. And then z is negative, but times the negative 5. So this is going to be plus 20. So sweet. So negative 18 plus 20 is 2. So x is equal to 2. Alright, hell yeah. So we did it. That took forever. Okay, so now we're going to do it kind of 3 or 4 different ways, because we learned a couple things in this book. One, we learned how to do things like from the text. It says put it into a matrix and then do what we're going to do next. So next we're not going to do it matrix, but we'll get there. And then once you do the matrix, it's going to be easier. But then you turn it into an echelon of ones. It looks harder, but they say you definitely need to learn that to do quantum physics. Alright, hell yeah. So then the next thing is, how could we have just done this just a hell of a lot faster? Like, they typically, like in the matrix, they do, they try to get this one first. You know what I mean? So, should we try to do that? Okay, so what would we do? We would multiply this by 3. So we're going to have 3x, and then this becomes 9y, and this becomes 15z. And now we're going to subtract it from this one. And then so this one becomes 0. 3x minus 3x, that's 0. Negative, so you got to be careful with this subtraction though, because we have negative 9 minus 1y. That's going to be negative 10y. And then you're going to have 15, but subtract 4. That's going to be 11z. And then here you're going to have negative 9 minus a negative 13. So that's negative 9 plus 13. And oh, I'm so bad at these. You know what I mean? In the comments, like, how do you get better at this? Negative 9 plus 13. Oh, so I got it. So, like 13 minus 9 isn't the answer, but it gets us kind of part way, because to to cancel out these negative 9s, I got to use positive. Oh yeah, so here's a method. Oh, hell yeah. Let's say negative 9 plus, this is going to be 9, 10, 11, 12, 13. It's all right to use fingers, plus 4. So there you go. This is negative 9. Oh, man, I'm just coming up with my own style. So negative 9 plus 9 plus 4, hell yeah, those cancel, and we just get 4. Man, but I don't see it. And negative 9 minus 13, it's like a nightmare. I know what, yeah, I don't even want to go that route. Okay, so, sweet, so this has got to be 4. Yeah, because we're going to negative 9, and then it's subtracting a negative. It's going to be plus 13. But we get 4, and now we got this rearranged. And so we do the same thing with this. No, what do we do? Do we do it with both of them? I think you do. Yeah, I kind of forget from the text, but yeah, you would want to do it to both of them. So now we're going to take this just to multiply by 2. So now we're going to go 2x. This was 3, but it's going to be minus 6y, and then plus 10z. And then so we're going to do that same thing and subtract. So you might add, you know what I mean, if this was a negative 2 to begin with, and that was positive 2x, then you would just add them. All right, hell yeah. So we got 0. We're going to have negative 6 minus a minus, so it's going to be negative 6 plus 1. It's going to be negative 5. Negative 5y. 10 plus 3, so plus 13z, because it's minus a minus. Alright, and this is going to equal... Oh, I forgot to do... Oh, are we already messing up? Oh, yeah, we totally messed up on this number, because this was supposed to be 3 times... This was supposed to be negative 27, and that was going to be negative 27 plus 13. And so let's try that same method. Okay, so we have negative 27 plus 13. That's going to be negative 13 minus... So I get it. So yeah, so if I do 27 minus 13, hell yeah, this is going to be 14. So negative 13 and minus negative 14 is negative 27. And I guess I can prove that by saying positive 13 plus positive 14 is 27. Sweet, so we're going to have negative 13 minus 14 plus 13, and this is going to be negative 14. So sorry about that. So this is negative 14. This one becomes 2x minus 6y, 10z is equal to negative 18. And then so we're going to have negative 18 minus... plus 13. So we have negative 18 plus 13. And yeah, I don't know why I'm so bad at this, but is that right? Negative 13 minus 5 is negative 18. I see that. Plus 13. And then we got negative 5. I like my new method on that. Alright, sweet. Okay, so now you would do the same thing. You would take these and be like, well, if I doubled this, and then we'd have negative 10y plus 26z is equal to negative 10, then I can subtract these two. So let's do that. Negative 10y minus negative 10y is 0. And we have 11 minus 27. 11 minus, 26. I like this method though. 11 minus 26 is the same thing as 11 minus 11 minus, so 26 minus 11 is 15. So these two things, negative 11 minus 15, I can see that now. That's negative. I mean, that adds up to, these two things add up to negative 26. I see that. And those things cancel. So we're going to have negative 15z. And what's next? So now we have negative 14 minus negative 11. So it's negative 14 plus 10. Okay, same thing. I can do this one real easy. Negative 10 minus 4 plus 10. I think I'm the only one that has come up with this method. I think it's a new method. Alright, so we got negative 4. Alright, booyah. So now we can see that z is 4 divided by 50. I feel like that's the wrong answer. 4 4 divided by 15. That's damn it. What did we say z was? Z was just going to be -4. Whoa. We should have checked ourselves before we wrecked ourselves on this one. Bummer. All right, let's try that one just a little bit slower. Yeah, and I think we can kind of just do it all in our head now. So we're going to have like these. If I multiplied this by 3 and then subtracted, these would cancel, so we have 0. And then we'd have -9 minus 1, that's -10y. And then we would have 15 minus 4, that's -11z. And then we would have -27 plus 13. But yeah, I still have to do this. -27, that's going to be -13 minus... oh, see, now I can see just a little better. -14 plus 13. And so this is going to be -14. Well, why did we mess up on this? Damn. Okay, so now this next one, we just multiply by 2. So this is going to be 0, and then we'll have -6 minus... -6 plus 1. So that's going to be -5y. 10 plus 3 is 13. Yeah, aren't we doing the same thing? Yep, 10 plus 3. This next one we're going to have -18, but it's just going to be minus 19. All right. Oh, so -8. Maybe I messed up here. -8. Yeah. Where did I? Yeah, that's bummer. That's bummer. Because -18. Oh, this is bizarre. Yeah, no, we did the first one down here, and we got, yeah, that was it. This one is related to that one. The second one, so I don't know where I made the mistake, but it was probably -18. Yeah, I accidentally added this, so that was wrong. But it's cool to catch your mistakes. Just like, where the hell did I go wrong? Because this first one I did -27 plus 13. This other one I messed up. So even right there, it's good to go back to your sheet of paper and then check it out. So we're going to go -18. But now we're going to, it's this one. It's -19. So that's the same thing as 18 plus 19. That's going to be 17, 37. Cool. So this is going to be -37. So we have -37. And then when we doubled this up, we're going to have, this is going to be 0. This is going to be, whoa, no, this is the double of that. So this is going to be 37. I know 35 times 2 is 70, but we'd have 4 extra, so we'd have -74. Okay, so now we can subtract these. So we got 0. We have negative... it would be -16, but it's going to be -15. I guess I see that now. And then this is -14 plus 74. I still don't know what that is, but I can factor 14 out of this. That's going to be plus 60 plus 14, -14. Heck yeah, so this one's going to be 60. Booyah. So now z is -60 divided by 15, and that's 4. Holy Toledo, -4. All right, sweet. So we're back to there. So now we're back to z is -4. And do we need to keep these equations? I mean, because essentially when you get into matrices, like, hey, this is your new matrix. You have a 0 there and a 0 there, and then, you know what I mean, something like that. All right, so, yeah, I guess we probably just should stick to this sheet of paper maybe, but we don't have any more room. But yeah, we got that, and then, so once we get, yeah, no, and then once you get that, then it's really plug and chug, you know what I mean? Hey, this becomes -44, and add it to, you know, this would be +44 minus 14, that's going to be 30, divided by negative 10, y is negative 3. Cool, so that's a check, and then you would throw both these just into anywhere. So cool. So now we're actually going to use the matrix form and see how they do that. And I'm going to go look at my text just so I don't make any mistakes. All right, hell yeah. So we're back, and so yeah, I think the matrix just works out really good because you do like 1, and then you do negative 3. And then you do 5. And I don't know if they call this, I think they call it an augmented matrix, where you actually draw a line right here, and then you do negative 9, and then you just keep the process repeating. Negative 1, negative 3, 19. And then you have 3, 1, 4, negative 13. And I should always just kind of double, like a double check, do a little glance, just to make sure we're good to go. Okay, heck yeah. So then in the book, and they do like the matrix, and then it feels like you're doing something. Hell yeah. All right, so what they do is just say, hey, let's get this number to be 0. You know what I mean? So what we would do is, I mean, what they do in the book is like, don't think about, I mean, you got to double this one, but think about you already did that. So what they say is just like, even just right here, you're going to subtract 2. You know what I mean? So that's just kind of what they do. So then your new matrix is just 1, negative 3, 5. I mean, I guess you'd have to write the whole friggin' thing over again. The bottom hasn't changed yet. So we're just working on this one. Well, obviously, we did that same thing. We just doubled these and then started subtracting them. So we have 2 minus 2. Cool. So that's going to be 0. So that's where you get that first 0. This one's going to be, and I guess you have to subtract this one first. You know what I mean? So it's negative 3 minus 1. Now is that, I feel like they, let's take a look at the book, because for this first go around, they're saying that this one's going to be 2 times 2 times 1. And then here's negative 1 minus 2 times negative 3. So yeah, so they're still saying this is, whoa. So they did it different. They said, oh, that's fascinating. Yeah, mentally, instead of taking this one, subtract this one, they're taking this one, subtract that one. And that, actually, mentally, that makes just way simpler. I don't know, mentally for me. It's the same thing, but now we can say, hey, negative 1, subtract negative 6. So that's going to be adding. Is that what they get? Yeah, they have, for that second one, they do negative 1 subtract negative 2 times negative 3. So that's going to be negative 1 plus 6. Oh, so it's fascinating, because I thought we did it the other way around, where we did negative 6 minus 1, which is negative 5. Oh, fascinating. But yeah, I'm going to do it like they do it. You know what I mean? Because it's probably the better way to do it. So this is going to be, and it's simpler to think of this number and then subtracting something else. So we have negative 1, subtracting a negative, and you got to multiply this. What we're doing is we got to multiply this by 2 to subtract the, I mean, you're taking, yeah, once you multiply this by 2, what they're saying is you take this one, subtract that one. That's the only little weird thing, because it just seems like I want to do a subtraction sign and then do that. But I'll get used to that. Okay, so we have, again, negative 1 plus 6, if you can see that. So that's going to be plus 5. Cool. This is going to be negative 3, but plus 10. That's going to be, because, oh, no, shoot. No, this is negative 3 minus 10. So it's going to be negative 13. Sorry about that one. This one, though, is negative, no, it's just 19 minus twice this. So it's 19 minus negative 18. So that's going to be 19 plus 18. And that's where you get 8 plus 9 is 7. And so you get 37. So positive 37. Cool. So we did the first little chunk, and now we're going to do the second chunk. And I think that's where they just do this all in one go. They don't do it all in one go. They take their time. But we're going to go 1 minus 3, 5, negative 9, 37. Because you can see that we could have done both those steps all at once and just been rocking and rolling. So we got 0, 5, negative 13. Hopefully I don't care if we make mistakes, because it's good to make mistakes and then go check them later. All right. So for this next one, yeah, we got to multiply this by 3, but we're going to do this, subtract that. So 3 minus 3 is 0. Booyah, we got our next 0. 1 minus, so we got minus and minus. So it's going to be 1 plus 3 times this. 1 plus 9. That's going to be 10. Now we have 4, but now this is minus. This is 4 minus 15. If it was 5 minus, why can't I not do these? If it was 5 minus 15, positive 5 minus 15, that would be a negative 10. But let's write this out. So we have 4 minus 15, which is 4 minus 4 minus 11. So sweet. So we're going to have negative 11. Cool. And, oh, bummer. I shouldn't have wrote this one in. My bad. But now we're going to have negative 13 plus 27. So we're going to have negative 13 plus 27. That's, that's negative 13 plus 14, right? So now we have 14. Hell yeah. Sweet. So now they're next in the book, what they wanted to do next. So that was, and I guess I just at least show you the page. You probably can't see worth a crap, but anyway. And then the next page, their goal is to get this 0. So let's do that. And that's kind of the main gist, because if you get this to be 0, whatever this is an equation for z. It's just an equation for z. It doesn't mean that either one of these numbers is z. It's saying z. If this is 0 right now, it would be saying negative 11z is equal to 14. And then you could find z. So we do the echelon method where you try to get this. If this is 0, 0, 1, whatever the hell this number is, which is going to be negative 4, so that's going to be the next method that we do. But we're still on kind of this method. So we're going to change this to 0. Now, we don't want to do anything with this one, because if you go 0 minus this, obviously, so that I do get. You know what I mean? From the matrix perspective, it's just like, well, you can't make this 0 by doing anything to this equation. And I think in the literature they kind of mention something. I just, like the technical jargon, I don't know. It's like you'll get it 5 years from now when you read the book again. You know what I mean? So I definitely get that from textbooks. Okay, but you can change this. Hey, let's multiply this by 2. And then we're not gonna do this. We're not gonna subtract them that way. We're gonna do like they do in the book. We're gonna do 10 minus 10. So that's gonna be 0. So we've got to write this again. Holy Toledo. But we will have a 0 here. We won't know what these two are, so I can't write those in. These stay the same. Negative 9, 37, but I don't know what these two are. So we're going to go 10 minus 10. Now we're going to have negative 11 minus a minus. So it's going to be negative 11 plus 26. See how I had to double this? I had to double this so these 10s cancel. Yeah, so I have to double everything. So I'm just keeping that in my head. But I don't want to do a lot of writing. You know what I mean? The whole idea with matrices is to kind of just simplify it. And if you did write it out, you don't have to write any of the characters, X, Y, Z. You don't have to write those out every single time, so that is nice. And this is my first, I swear, this is my first time ever doing this stuff ever. No one ever taught me this. Okay, so we have, alright, so we have negative 11 minus a minus. So we have negative 11 plus 26. Yeah, and I don't know any way to do this, but this is a pretty good method. Negative 11 minus 11. No. Negative 11 plus 11 plus 15, right? 11 plus 15 is 26. So we're going to have 15 here. And now we're going to have 14 minus, so we got 14 minus double that. 35, again, doing the same thing. 35 times 2 is 70 plus 4. So we got minus 74. So this same thing is 14 minus 60. I see that one real fast. So sweet, we're going to have negative 60. Okay, so now again, this doesn't say that z is negative 60. This says that 15z is negative 60. You know what I mean? So if I wanted to solve for z, hey, it's you know, it requires another step, but z is negative 16 divided by 15. Z is negative 4. Cool. And just quickly to see what they do next. Once they get negative 4, then they just go back to any of the other equations and say, and then so they just go back to this one and say that 5y, you know, they spell this one out, 5y minus 13z, but now we have that negative 4, is equal to 37. So now you can see that this is, well, if this was double, it would be 26, but it's doubled that. I don't know what 26 times 2 is, but I do know what 25 times 2 is. That's 50, plus an extra, this is 52. All right, so now we have positive 52 over here. We got to subtract it. Damn it, I hate this stuff. So we have a 37 minus 52. Have no idea what that is. But 37 minus 37 minus, let's just guess. Let's just guess 20, because I want to get on with life. This would be 57, too much. Too much by how much? By 5. So maybe negative 15. Oh, see, that was pretty sweet. So I do know what 35 plus 15 is. That's going to be 50. And then 2. So this is 52. Alright, so we have a check on reality there. And our answer is negative 15. So we're going to have 5y is negative 15. Cool. Hell yeah. And then so y is negative 3. Alright, sweet. So and that's all they did for there. So, I mean, you're using the matrix just to eliminate writing x and y and z. And to do your, I think they call it, well, they say something about back substitution. I think, is that what we're doing right now? Like finding z, using the Gaussian elimination procedure. So that's what we're doing. You know what I mean? You're getting that to be, you're getting this one to be 0, maybe that one to be 0, and then lastly that one to be 0. And then hell yeah, you have this, and they just say, hey, now you have AZ is equal to B, you know what I mean? So Z is B over A, you know what I mean? Whatever. And but then you're gonna try to get this to be a 1. That's gonna be our next step. So that's pretty sweet. All right, hell yeah. So and then how did they find the x? So once they found that y is negative 3, then they just throw it into what, the first equation? Yeah, sweet. So then they actually just throw it into this equation, and it's the one that makes the most sense because you have x minus 3 times negative 3 plus 5 times negative 4 is equal to negative 9. So we have plus 9 minus 20 is equal to negative 9. All right, so this is going to be negative 18, and then bring this over plus 20. X is equal to 2. And is that what we get? Is that what we've gotten all along? I kind of forget. We got y, z, and then heck yeah, x was positive 2. Okay, sweet. So, yeah, I would say I dig. You know what I mean? Like, I think it's faster. I see it, but we just kind of want to learn the procedure because this is just the first pages of a book that gets hella technical, hella fast. So anyway, the next thing is that, hey, we're going to try to get these to be 1s. And we're going to use, so once these are all 1s, you can see that, hey, z is that number, y is that number, x is that number. And so I've actually haven't read too much, but I think I can just kind of wing it. But we're not gonna do their example in the book. Oh, we should hella. Now let's keep with this one because this one's fascinating, and I need to print off some more sheets of paper. All right, hell yeah. So I got some sheets of paper, but so we don't have to do everything over again. You know what I mean? Hey, we get to here. You're gonna have to do all these same steps. you're going to have to get all those to zeros. But you want to get this to 1. You know what I mean? So actually you just do an operation just on this row. You don't have to worry about the other rows. But what you're going to do is 15 divided by 15. You know what I mean? It's the same thing to get z by itself. To get z by itself, you're going to go z is, you're going to divide by 15 here, and then divide by 15 over there. You know what I mean? Now you get 1 for your, I think this is the matrix because you say operator, I think. I don't know. Are these operators? No. I'm just making stuff up. I just thought it was funny. I call this the matrix. But anyway, all right. So let's not start over. I got some fresh sheets of paper. I'm just gonna rewrite this. Catch you on the flip side. All right, hell yeah. So looks like I didn't rewrite it. But anyway, always good just to. So we got 1 0 0 -3 5 0 5 -13 15 and -9 37 -60. All right, hell yeah. And again, we already I shouldn't have, like, why did I even do that? Because now we just know to get that. I mean, this is the bummer. It seems like you have to write the matrix 1,000 times, but whatever. I guess we're just learning. Because I think you would have this in your calculator maybe, and then you would just tell it what to do. I have no idea. But anyway, I mean, because honestly, this feels like more writing. But no, it simplifies it. I get that. For bummer, dude. You know what I mean? So this was supposed to just be 1 right there, because we already did it. And so this is going to be -4. So there you go. So we have our first 1 over here. And I think they're throwing us a bone on this one where, hey, this is already 1. Sweet. Okay, so the next one, though, is like, what do? Do you try to get this to be 1? Well, no, you could, but then you'd have something over there. I mean, you could do it. Like, I see how you could do whatever steps you want in, like, whatever order you want. But by the... Yeah, you don't want to trip yourself out. But yeah, you could divide everything by 5 here, and then get this to be a multiple of that. But I mean, it is nicer just to, well, I mean, they get this to be 0, and it's not going to be nice anyway, because you got to get this to be a multiple of this. So what do you need to, you need this number to be 13. So 5 times what? And you can even do that. You can be like 5 times what is 13? Well, you see that this what is 13 divided by 5. So we're going to take this top row and multiply everything by 13 divided by 5. So yeah, this no longer becomes 1. You know what I mean? Such is life. And yeah, and maybe they don't do that. But we'll see. Oh, just a second. No. Holy Toledo. Oh, hell no. You know what I mean? That, like, why do extra work? You know what I mean? So I'm at least picking up, like, you know what I mean? It's like, holy Toledo. The whole idea of this thing is to do less work. This equation jives. You know what I mean? So we have 1z is equal to -4z. You know what I mean? So, hey, so if I want to get this to be 0, I just take this and multiply this by 13. I'm so glad I caught that. That was like an error, catching an error. So I was really proud of that one. Anyway, so then when we do that, then we can take this, subtract this. So we have, but actually we're going to add it actually. So we're going to have, if we multiply this, I mean, you could multiply it by a -13. I don't know why you'd do that to subtract. But yeah, you would just multiply this by, and I don't know why you'd multiply them, whatever. You do you, just to make sure when you add the negative numbers together, you're not just losing your mind. But if we do this times 13, then we'll add these. We'll add these 2 rows. So 0 times 13 is still 0. So 0 plus 5 is still 5. So anyway, so I guess we'll write this one more time. 1 0 0 -3 5. Now we don't know these 2. That's what we're going to try to figure out. But this stays the same. We're just mentally saying, hey, multiply. And that's what they do. In the book, they just say, hey, go like this, and this is going to be 5 plus 0 So in the book, they're going to say this is 5 plus 0 times 13. Then they're going to say this is going to be negative 13 plus 1 times 13. Cool. So this becomes 0. Then they're going to say this is 37 plus negative 4 times 13. I don't know what 4 times 13 is. I could probably do that though. You know what I mean? Because I do know what 4 times 3 is. This, or 4 times 10 is 40. But then 4 times 3 is 12. So it's going to be 52. Hell yeah. Got there a little faster this time. Alright, so, and, oh, is it negative or positive? So we have, this becomes, I mean, yeah, 37. Which one are we even doing? 37. Oh yeah, 30. Yeah, we haven't done it yet. So 37 plus 52. No. No, yeah, we did it. 37. Oh, this is 37 minus 52 though. So we're going to have 37 minus 37. And then we have plus, I forget this one. Is it 15? No, it's got to be, so 37 minus 37 minus 15. Because minus 37 minus 15 is 52. Cool. So we're going to have minus 15 here. Hell yeah. So now, heck yeah, we got a 0 there. Now we can actually get this one. Because this essentially says 5y is negative 15. So let's get y by itself, divide by 5, and now you have 1y. 1 is your operator. I don't know if they say that right, but anyway, is negative 3. So that's going to be the next thing we do. All right, we're going to write this. We have 0, 0, 0, negative 3. This becomes 1. And this becomes negative 3 over here. This is 0, 1, negative 4. So now you can see that z is negative 4. Y is negative 3. And we have a couple more steps to do. And yeah, are we on the fancy one? Yeah, we're on the fancy one. You know, this is called the echelon. Echelon of 1 or something. I don't even know. Who cares? Like, that's what I don't like about textbooks, is they have to use very precise language. Yeah, it just gets a little heady. But anyway, so now, yeah, we do that same thing, and because now we're going to try to get this one to be 0. That's the order that they go. They do this one last. I don't know why. But anyway, they just do this one next. And so we're going to say, hey, so same thing. We have a z, 5z. This is 1z. So let's multiply this by 5. And then we're going to actually subtract. So sweet. So we're going to have, and when we do that, this whole thing gets manipulated. Is that right? Yeah, don't we lose? I feel like you would lose this one. Is that true or not true? How did we not lose this one? No, we lost it. Yeah, oh, duh. We're just taking this equation. Yeah, because this equation has 2. I don't know why I'm getting so messed up on that. Yeah, this equation is super simple. It just says 1z is equal to negative 4. This is the same thing as saying 5z is equal to negative 20, and then we can subtract this. Well, you know, it doesn't, this is 0x plus 0y. So when we subtract, or add, yeah, subtract these. So we're going to say 1 minus 0, 0. 1, so that's 1. Negative 3 minus 0 is negative 3. And now we have 5 minus 5 is 0. And then for this one, it's going to be negative 9 minus a minus. So it's negative 9 plus 20. Alright, that was a faster way to do that. So we have 11. Alright, hell yeah. So now we have 0, 1, 0. 0, 0, 1, negative 3, negative 4. These are already solutions. We're almost ready for this to become a solution. What do we need to do? I think we need to do one more operation where we have to multiply this by 3 and then do that. So if we multiply this by 3, this becomes, I don't want to write, I want to do it in my head. So this is 3 and negative 9. And then so we're going to say negative 3 minus so this one we would add them. So if this was 3 and negative 9, so negative 3 plus 3 is 0. Alright, so we got 1, 0, 0. And then 11 11 plus negative 9. 11 plus negative 9. It's 11 minus 9 is 2. Sweet. Oh yeah, and that x is equal to 2. 0, 1, 0, 0, 0, 1, negative 3, negative 4. Hell yeah, we did it. We did an echelon approach. And, I mean, I make long videos, so we might as well do this one again with the actual problem that they use. They're going to use, you know what I mean, this series. Oh, what? No, I think we're done. Because they actually just say, hey, augment, like, hey, we got this matrix, let's augment it. So they don't even do all the work that we did. Because you still have to use the substitution process to get these to be zeros. We got that. And then you have 5z is equal to negative 15. Cool. Divide by 5, you get this to be 1. You know what I mean? Cool, we get that. And then they started getting these to be zeros piecewise. And so we just did it. So we did our first, we reduced row echelon form. So place the augmented matrix. So we made it into reduced row echelon form. And heck yeah, so we have an echelon of 1s. And they basically spit out the answers. You know what I mean? So hell yeah, check on reality. And that was pretty cool. That was kind of my first linear algebra. I've never even heard of linear algebra. My brother was like, yeah, you should do linear algebra. And you're just thinking, well, I did that in 8th grade, I think. But no, they say this is how the world works. You know what I mean? They say it's the most powerful mathematical tool since not caring. You know what I mean? So hell yeah, the most powerful mathematical tool. We're going to learn it. So booyah. So thanks for joining me. That was my first video on linear algebra.